Methane. So when we look at melting permafrost and melting frozen lakes, there's a lot of methane in the tundras, in these frozen lakes. So that's what we see here in this image. People are actually breaking open and burning the methane that's getting released. Methane is also a greenhouse gas. So we talk a lot about carbon dioxide because we're producing a lot of carbon dioxide, but methane is also an extremely potent greenhouse gas. In fact, it's more potent than carbon dioxide is. So as the planet gets warmer, these lakes are melting and releasing tons and tons of carbon dioxide, not carbon dioxide, methane into the atmosphere as well. Okay. The habitats are changing very rapidly. Polar bears, for example, they hunt on the sea ice in the Arctic. They're losing their hunting grounds. So a lot of them are actually starting to starve because they can't get enough food to survive. So their habitat is changing, and this is leading towards endangerment and hopefully not, but maybe extinction. And then here, amphibians are believed to be one of the organisms that's going to have a huge problem with the climate changing so rapidly because amphibians enjoy nice, moist, wet environments, and they need lakes, they need ponds in order to survive, and those are slowly kind of drying up and disappearing as the planet heats up. Desertification, we're actually seeing, remember I told you the magic number was 2 degrees Celsius. Well, 2 degrees Celsius, that's an overall average temperature for the planet, but where we are right now, some parts of our planet have actually heated up to past 2 degrees Celsius. So as a result of that, they have actually seen bigger change in their ecosystems there. So in desertification, it warms up so quickly that the plant life can't keep up. They begin to dry out and they die. So that's what we see with desertification. As we continue with the climate getting warmer, we are expected to see more extreme weather as well. So we should expect to see more droughts because as the planet heats up, we'll have less precipitation overall, more evaporation occurring. So we should expect to see more droughts, and we are seeing that, especially in just about actually every continent, in India, Australia, parts of Europe, even South America and parts of the United States, North America, we're actually seeing more droughts, more extreme droughts, we should say, because of the change in temperature. In Europe, they've seen some of the hottest temperatures they've ever recorded. So in recorded history, since they've been taking temperatures, hottest temperatures they've seen in the last couple of years. In California, in the last few years, it's gotten so hot that these mussels that were actually caught during low tide, they were caught up on the rocks. It was so warm that they actually heated up and cooked within their shells. In Mexico, I think it was either last summer or the summer before, they had a hailstorm in July. And this was a crazy hailstorm. There was so much hail that it actually buried cars. So this isn't snow you're seeing, this is actually hail. So this was in July in Mexico, and that's how much hail actually fell. Floods, we're definitely seeing more floods as time goes on. A lot of times people are like, oh yeah, this is the flood of the century. Oh, this is crazy, it hasn't happened in 100 years. But now we're seeing floods like every single year. So these huge, massive floods every single year. And then hurricanes. Hurricanes seem to be getting more and more powerful, and that's what scientists estimated or hypothesized back 20 years ago, 30 years ago about climate change, that we should expect to see stronger hurricanes, and that's actually evidence. This is actually stuff that they said back then, and we're actually starting to see that now. And then as far as pathogens goes, with pathogens, the more the tundra permafrost melts, we're expected to see more emergent pathogens. And the reason for that is it's believed that there are actually frozen viruses up there, maybe even frozen bacteria. So we have these frozen pathogens up there, and as the permafrost melts, they're actually going to get released. So that's one hypothesis going on with pathogens. And also we're going to see more pathogen success. And one good example, again, here's evidence, is flesh-eating bacteria. We're starting to see more and more cases of flesh-eating bacteria. If we just look at here in the United States, we're seeing a lot more in Florida and California, and it appears to be because flesh-eating bacteria actually is more successful in warmer waters and stuff like that. So people are actually having cuts on their body, they go to the beach and stuff, and flesh-eating bacteria floating around the water gets in and is actually killing people or making them very sick or having to amputate their leg and stuff like that. So that's another problem that we should expect to see as the climate changes and gets warmer. All right, and last thing with climate change is ocean acidification. And this is a huge one. Ocean acidification is going to be a major problem here because I shouldn't say most, a lot of the carbon dioxide that is released by us, by cars, planes, all of our transportation, cows, stuff like that, it is actually dissolving into the ocean. So a huge portion of that release, about 40%, gets actually dissolved into the ocean. And as a result of that, when it reacts with the water, it actually breaks apart and releases hydrogen ions, which is basically making the ocean more acidic. So the ocean is becoming more and more acidic over time. Again, we have data for this as well. As people have been taking samples, we're actually seeing the ocean become more and more acidic as we keep dumping this carbon dioxide in the atmosphere, and it also dissolves into the ocean. So we're actually seeing the ocean acidify. And the reason why that's a bad thing is because corals and many shelled organisms like clams, oysters, crabs, lobsters, they actually need the calcium and another molecule in order to make their shells. And with all these hydrogen ions floating around, it's actually stealing materials from them. So it's actually becoming harder and harder for organisms to actually build their shells. Plus, if the ocean becomes too acidic, then what's going to happen is the shells will actually start to dissolve. So two problems going on there. As the ocean becomes more and more acidic, the organisms have a hard time making their shells. As it gets too acidic, once it gets too acidic, then their shells will actually start to dissolve. That's what we see here. So it's actually the hydrogen ions compete for parts, the materials necessary to build their shells. All right, and then we have the hole in the ozone layer. So done with climate change, now we're moving on to the hole in the ozone layer. Now the hole in the ozone layer is caused by molecules called CFCs, chlorofluorocarbons. And these were chemicals that we used to use in propellants and refrigerants. And basically when they get released, let's say in hairspray, there used to be CFCs in hairspray. When people would spray their hair with the hairspray, it would release CFCs as well into the atmosphere. Well, when CFCs get into the atmosphere, it breaks apart and it destroys the ozone. So what exactly does the ozone layer do? So the ozone layer actually helps reflect harmful UV rays. So as the UV energy from the sun hits the ozone layer, UVA gets through, a little bit of UVB, and most of UVC just gets reflected away. So this ozone layer is basically a sunscreen for our planet. That's basically what it is. That's why you put sunscreen on, right? You put sunscreen on to reflect the UV rays away. So that's what the ozone layer does. So when the CFCs get up into the atmosphere, they break apart that ozone layer. Basically, it's crazy. It's actually connected to the UV radiation here. So when the CFCs get up into the atmosphere, the UV radiation breaks off a chloride ion from the CFCs, and one single chloride ion can destroy up to 100,000 ozone molecules. So this has actually caused a hole in the ozone layer. And if this keeps on happening and we lose this, then all life on our planet is going to have a huge, huge problem. People and animals and plants that are exposed to the hole over Antarctica, at the tip of South America, parts of Australia, New Zealand, stuff like that, there's higher rates of cancer because UVA, UVB, UVC, when organisms are exposed to that, it damages DNA and that can lead to cancer. So we need the ozone layer. It's something that is a necessity. It's something that we want there. So that way we aren't exposed to all this UV radiation, which would lead, of course, to cancer. So we've actually been able to follow it. We've been able to follow the whole of the ozone layer. And when we actually realized what we were doing with these CFCs were banned. So a whole bunch of people got together, or a whole bunch of countries got together, and in the 1980s they signed the Montreal Protocol, and that basically banned CFCs. But as I said earlier about pollution, these molecules, these chemicals tend to last for a very long time. So we should expect decades upon decades before we actually see a change and the ozone layer actually start to heal. All right, here's an image showing how the ozone is actually broken apart. So here's a CFC. It gets broken apart. Here's a chloride ion. It breaks apart the ozone, makes a whole bunch of oxygen. You might be thinking, yay, good, oxygen. But that's not good for that layer. Okay, we want that ozone layer to be there in order to protect our planet. All right, and then finally, the very last thing for pollution is plastic. So, plastics are a bad thing. They're a man made thing, and they're recent too. Plastics have not always existed. So, this recent man made miracle marvel that allowed cheaper production of containers and stuff like that has been awesome as far as the economy goes, but not as far as the health of the planet. So, plastics can take hundreds to thousands of years to break down in a landfill when they're buried. Good thing is when they're exposed to light, they can break down faster, but then there's a bad side to that too. So a lot of the plastics that are floating around in water, in the ocean, in rivers, lakes, streams, when they're exposed to UV radiation, it actually breaks the bonds in the plastic and starts to actually break the plastic apart. Might be a good, you might sound like a good thing, but it's actually not, because what happens is you get microplastics. So it can only be broken down so much by the UV radiation, and then you're left with microplastics. And those microplastics are often toxic. Okay, so we've dumped tons and tons of plastics into the ocean. A lot of marine life suffer from it. We see birds suffer from it too because they eat plastic, thinking that it's a food source. Fish, and even ducks and stuff like that. So plastic causes problems for a lot of marine organisms and organisms that live in rivers and lakes and streams. And another reason why this is a bad thing too, when we go back to the microplastics here that are toxic, there has been so much plastic broken down in this way down to microplastics that it's in just microplastics are in just about everything we eat and drink. So every single week, there's been a recent study that shows in a week, you eat about 5 grams worth of microplastic, which is about a credit card worth. So we eat a credit card's worth of microplastic a week, and all of that adds up to about a half a pound a year. So we eat about a half a pound of plastic a year. They did studies in the US and found that about 94% of tap water has microplastics in it. And you might be thinking, oh, good, we drink bottled water. Well, when you cook stuff, a lot of people get water from the tap in order to boil stuff and things like that. So that is exposing you to those microplastics. And then in Europe, there's like a 72, 74% amount of microplastics found in their drinking water there. So we have created this thing, but it's actually turned into a bad thing for us where we're actually starting to poison ourselves. So it's actually become a problem. Okay, so it's definitely something, not just this, but all the different types of pollutions that we do, we need to stop and take a look. Is what we're doing worth it? Is it sustainable? That's the biggest thing. Is what we're doing sustainable, or is it going to cause bigger problems further down the line?